in the Telegram.
Bye, all.
Thank you.
Thank you. Bye. We've got one more. We actually have one workshop, but I know it's been quite a long evening. Robert, would you like to get started?
Yeah, sure. Let me share my screen. All right. Can you hear me okay? Hello?
Yeah, hello, can you hear us?
Okay, yeah, I could hear you guys fine. I just wanted to make sure everything was going through.
Thank you.
Yeah, let me get started. Okay. So yeah, my name is Robert. Today I'm going to talk about blockchain decentralized AI and ROFL, which is something that we at Oasis are building. Just to start off, this is me. I'm not on camera right now, but that's my face if you're curious. I'm a BD specialist at Oasis, so my work is involved in building out our ecosystem and getting more dApps, but also I think it's important for education to have more outreach and teach people what you can actually do with blockchains, just like the last talk did. I think this will be kind of an extension of that. So I'll get right into it. So basically, I'm going to talk about 3 key aspects and how they all unite together, and that being privacy, crypto, and AI. So let's just get right into crypto. What I mean by crypto, of course, is blockchains. These are pretty much synonymous. We just call it crypto because it sounds cool. But what is all the fuss about? You maybe have some idea now, especially since this is a blockchain society. But just to recap, a blockchain is a digital distributed ledger, and it securely links together these blocks through cryptographic hashes. All of this is to say, if you break it down further, that it's spread across all over the world, so many different machines. It comes to consensus about some form of data and computation, and then it will permanently store that, and that's what we call a ledger, at least a digital ledger. And then the cryptographic hashes are a way to remain tamper-proof. So by having this cryptography, we can use private keys and have public keys associated with those and do things like make transactions that only unique individuals can sign without other individuals maybe impersonating or otherwise hacking in some sort of malicious way. So these 3 features combined together is what we consider a blockchain typically. And common examples are Bitcoin, Ethereum, of course. Oasis, we also have our own blockchain. I just want to get into a little more of the key features. So typically, not always, blockchains are permissionless, meaning that anybody can participate in validation. They're decentralized. So again, it's distributed all around the world. And this means that no single party can decide that consensus or cheat. If one person's deciding the rules, you might as well just use a database. And typically, they are transparent, meaning that all the transaction data is visible to the public, meaning you could just go on a block explorer and see everything that's happening. Nothing is private. This is typically what a blockchain is known for. Of course, there are exceptions to every rule. So there are permission blockchains, and these can whitelist validators. This is often popular with traditional financial institutions. Some have varying degrees of decentralization or centralization. So, I think like Ethereum is very decentralized, something like, well, I won't name names actually, but, there's various rollups and things like that, which have roadmaps where they're currently not very decentralized, but they're getting closer to that in the future. And you can look that up for yourself. There's also private blockchains, and these allow for transaction data to be hidden from the public. Now, this might be considered a negative from some people's perspectives because we want this kind of transparent, verifiable, open source world. But at the same time, there is a lot of utility in having privacy enabled on something that is still accessible to the entire world. And in the bottom right here, I just have the blockchain trilemma, which is kind of summarizing these issues of scalability, security, and decentralization. This is something that's been trying to be solved for quite a long time now, over 10 years, I would say. And technology is getting better, but ultimately, if you want to have greater scalability, you have to make some sort of sacrifice in the amount of nodes that run a certain computation or your trust assumptions. Okay, so that's all about blockchain in a nutshell. What about privacy in a nutshell? First of all, why do we care? Well, privacy, philosophically speaking, is a fundamental human right. This is something that in Western nations, especially, we feel should be true, that everyone should have some degree of privacy in their lives and in the things that they use, and et cetera. Now, as it comes to the actual internet and digital privacy, we've seen that the internet has grown a lot, but so have the scale of data breaches and hacks, and that is no good. That is bad. So these are just two charts summarizing a very similar trend that we've seen over time, that we just get these larger and larger hacks, data breaches, and it affects, at this point, pretty much everyone that has touched a computer has been affected. It affects billions of people. You've probably had some sort of data leaked at this point, and even if you don't know it, and that's not great. So there's various solutions that we can implement in order to try to mitigate these sort of leaks, and it's always good to implement best practices, even if you're using a centralized server. But sometimes that fails. So one of the things at Oasis that we've really focused on is the power of TEEs. So first of all, this TEE is an acronym that just stands for a trusted execution environment. And they're really complicated. So what does it actually mean? Let's talk about that. Well, one way you could look at it, and if you go to the link in the bottom left here, I've put it up for you if you're really curious, but this is a 118-page document talking about Intel SGX, which is a form of trusted execution environments. It's developed by Intel, the company. And basically, you can read all about how they implement this, but it's 118 pages, so we're not going to talk about it here. Let's try to simplify this a bit. If we look at this diagram, okay, this probably makes a little bit more sense. We have some non-secure worlds of computation and untrusted apps. This is just kind of transparent, typically operated apps on some machine and running in the cloud, perhaps. And then on the right side, we can see that there's the secure world, and this is running inside a TEE. And now there are trusted apps, and there's a trusted operating system. And all of this is rooted in protected hardware resources. This is still a little vague, but it at least hints that we're running all of this based on a specific type of hardware. And if we go back and remember, we were talking about Intel SGX, this is, Intel is a CPU manufacturer. We can see that these TEEs are based on a hardware level of security and trust. That is the core magic sauce, I guess, behind TEEs. If you really want to get simple, because maybe the explanations are too complicated, or you just want to have a simple framework to think about this for the rest of the talk, I would say just think of TEEs as a black box for computation, and that is what gives you privacy. We take some input, we put it in the black box, we get some output. It could be data, it could be computation, whatever it is. And this runs, again, at the hardware level, and so it could be in the CPU, or it could be in the GPU if you're doing things like large language model inference or other things. The way all of this works, in order to achieve verifiability, which is what we care about, is through what are called attestation mechanisms. And the exact way that these mechanisms work is not important for this talk, but there is a way that you can have this black box function in a way that outside observers can feel confident that what has been done correctly and done according to a set of rules that was determined in advance that everyone can agree upon. So that's privacy. We've talked about crypto. Now let's see how we can combine the two. If we add these TEEs to a blockchain, what do we get? Well, now we have a smart contract, and we can have some encrypted data, perhaps. We can send it into this black box, and we can get some encrypted result. So what does that look like? If we run this specifically with an Ethereum virtual machine, we get something called Oasis Sapphire. So this Oasis Sapphire is something that we've built. It's been live on mainnet for 2 years now, and it is the first and only confidential EVM blockchain that is in production. There's varying definitions of what EVM means sometimes, but in Sapphire's case, all of the smart contracts can be written in Solidity. All of the familiar tooling that people use, such as Foundry for development or Ethers for sending transactions, MetaMask for wallets, things like that, all of that still works as normal as it would on Ethereum or Arbitrum or some other EVM chain. So we truly do mean EVM. Sapphire works under the hood by having a network of nodes that all run this Intel SGX I mentioned earlier. You don't actually need to run a node yourself in order to use the network, but this is what's going on behind the scenes, essentially. And what this gives you as a user or as a developer is that the transactions, the call data, the smart contract data, all of this gets encrypted by default. So when you set a variable to private on Sapphire, it means that it's truly private. You can't look at a block explorer or decode some hex data in order to uncover that information. So privacy on chain is actually extremely useful. There's some obvious use cases that might come to mind. For example, DeFi, we could just add confidentiality to it. So if we have a DEX, then like Uniswap, then what if we had private swaps? Instead of everything being public, now we have confidential swaps. That's pretty straightforward. We could get a little more fancy and create, let's say, a private lending protocol. And in this case, you can, let's say, hide the liquidation thresholds on a loan. On a public network, you can actually see, you can ascertain this information about when a person is going to be liquidated on their loan. And therefore, there's the potential to manipulate the price of their collateral in order to cause that liquidation and cause them to lose money to your gain. So in principle, it would be good to hide this. There's other areas, though, that would be valuable with the addition of privacy. DAOs, I think, are a perfect example where in real life, non-blockchain voting systems, like with elections, these are typically run in a private way where any individual vote is kept hidden from the public, and then maybe the aggregated results is publicized at the end, only after the vote is concluded. And this is something that I think most nations have, all stumbled upon or I guess come to the conclusion that this is a good thing that we want to have. So why not also have it on chain? Well, currently on chain, you can't really do this on other networks. They're public, and therefore, when someone casts a vote, you can see what function that wallet called, what data it sent with that function. Everything is just kept public. This, I think, is, in my opinion, not very desirable. So we actually built in-house something called Block Vote, and you can go to the link here, just vote.oasis.io. You can just type it in, and it is an application that allows you to have private votes, not just on Oasis, but on other chains by routing through our network. And there's also other ways that you can implement privacy on blockchain applications that are not in a specific category. For example, like on-chain access controls. You could have a decentralized key management system. So there's a lot of creative use cases that people have come up with and will probably continue to come up with. But I just wanted to list a few of maybe the simplest ones or the most interesting ones. So I'm going to talk about Block Vote very briefly. This is just screenshots of the page. I'm not going to do any demos in case, who knows, right? My internet goes out or I have network issues, but this is just screenshots. So we have Block Vote here, and you can see, if you've created any polls, but at the top you have create new poll. When you click that, you can see, you can type in your question and the answers. On the right side here, this is where I think the really interesting part is. You can choose what chain you want your vote to be on. You can also choose what token or NFT the voters need to have in order to vote. For example, if it's a DAO, it might be, for example, Aave is a very large DeFi platform. They have a DAO. And so if you have that token, you can participate in votes. So this can basically read those balances on another network and weight that person's vote accordingly. It could be one vote per wallet. It could be proportional to the number of tokens or some other function. And yeah, basically that's how it works. And then of course at the top here, you can make it a hidden poll. So the whole point of this is not just to be able to do a vote managed in a cross-chain way. The whole point is you can have a vote on a network that is not private, but the vote itself can be private by routing through Oasis Sapphire. And all of this is handled for the user, for the developer, through this smart contract system and through this front end. And there's also gas sponsorship, because we understand that people are not necessarily all going to want to have to figure out how to acquire the gas token for a new network if they're not a native user, and that would be a large friction point. So as the poll creator, you can actually just sponsor the gas for all of the expected users. If you think you're going to have 1,000 votes, you can say, okay, here's 1,000 votes worth of gas up front, and if it doesn't get used, of course, you can get that reimbursed to your wallet. But it's a pretty elegant system, in my opinion, pretty cool. So definitely check it out. But there's other use cases that I haven't really talked about yet. So let's get into that. So we talked about DeFi, DAOs, and other stuff. Well, what goes beyond other? What have I not mentioned here? How about AI? I mentioned AI at the start of the talk, but I haven't really mentioned anything else about it. How does that fit into the picture with blockchains? What if we were to combine AI with blockchains? Well, first of all, we kind of have to understand what we mean by AI, because it's a very broad topic and there's a lot of different definitions and different opinions. So I'm going to narrow in on a specific type of AI. It's not all of AI. But typically we mean large language models. These are LLMs, and these are things like chatbots, for example. If you've ever used ChatGPT, probably you have at this point, or Claude, then you've probably used an LLM. So DeepSeek is another example, which is open source. There's also image and video generation, so generative AI, what we call it. Midjourney would be one example. It could also just be productivity tools, various different apps that people built. So AI is pretty broad, but for now we're going to focus on LLMs, because I think that is probably the most burgeoning sector of AI and has gotten most of the attention lately. So typically they require GPUs for training as well as inference. Think of like an NVIDIA chip, something that you would use to play video games, but can also be used for AI, of course. So the outputs of these LLMs are actually non-deterministic, which means that they don't give you the same result every time. There's a degree of randomness, and this is controlled through what is called temperature. But suffice to say, if you had a network of many nodes on a blockchain, and they were all trying to come to consensus about the same LLM response, well, they're actually going to get different responses. So it's going to be very difficult for them to come to consensus on that. So that kind of poses a problem for running these LLMs directly on chain. Also, the fact that LLMs require GPUs and blockchains typically run in the CPU, that also would pose a problem. And they're also very compute intensive. The computation, even for a single prompt, might be 50 cents or $1 worth for some output, which running across 1,000 different blockchain nodes, that can get very expensive very quickly. And to add to all of these problems, blockchains also can't access the web. And we like to have our LLMs being able to access the web and use data from the web, for example, with doing research and analysis and things like that. So without a trusted oracle, you can't do this on a blockchain. So there's a whole bunch of issues that arise if we try to do on-chain AI in an easy way. And it turns out it's not so easy. So instead of worrying about blockchains, maybe we don't need to worry about it. Maybe let's just worry about private AI. That would be the first step. Currently, things like ChatGPT are public, or they're public in the sense that your data is publicly shared with the company OpenAI. It's not publicly shared to the world, perhaps, but it's not kept private just to you. You don't really have control over your data. And this is not just true for OpenAI. I'm not singling them out. It's true for probably most LLMs that are available on the web right now. So what if we just focused on off-chain, but having this privacy? Well, there are actually centralized cloud providers that offer the use of these TEEs. So it's not just Oasis that's using these. This is not something we invented. Google Cloud, Microsoft Azure, you can rent a TEE essentially and build your application inside of that, and that would work. The question is, though, can we trust these providers? And if you do trust the providers, why are we using blockchains at all in that case? Well, in my opinion, we should be using blockchains as much as possible, especially for applications with sensitive data or handling lots of value. And the reason we do that is their ability to be persistent and to be decentralized, but also to be able to control your own data, essentially, to have control over your own funds or own information. And blockchains have really enabled this to a large degree. So another thing that they've enabled, of course, is verifiability, being able to actually confirm that some computation was done in the way that it should be. So let's just think about a few questions for a second. How do I know if I'm using an LLM that I'm receiving outputs from the model that I actually paid for? What if I give some data to ChatGPT? How do I know that my data there is being handled appropriately? How do I know it's not being given out, sold to a third party, trained on for the next generation of models? How do I actually ensure that besides some privacy policy that's written on a web page? And also, how do I ensure liveness? Sometimes things go down, and that's understandable, but I might be running a business that's using these large language models, and I want my business to be running 24/7, not have any downtime. And maybe it's like some AI agents, for example. And if the underlying service goes down, then I'm losing money, and that's not great either. So liveness is definitely a desirable aspect, even in centralized Web 2 services, like any cloud provider. Liveness is, of course, very important. For the question of am I getting what I paid for, I just mocked up this chart based on current API prices. So OpenAI has this model GPT 4.5. It's very expensive, but people seem to really like the outputs and the responses that it gives. So for many people, it's worth the money, and that's great. But you can see here that it's $150 per million tokens. That's the unit. Whereas Microsoft 5.4, which is a different model, that only costs around 14 cents per million tokens. And if you zoom in, you can kind of see that here, or maybe it's 26. It depends on the provider, of course. So it varies a little bit, but it's roughly 1,000 times more expensive is the point I'm trying to get across. And so if I'm paying 1,000 times more for the model on the left, I really want to be sure that I'm getting the model on the left. If I'm getting the one on the right, I'm going to be pretty upset. So how do I verify this? And how do I solve this? Is there a solution? Well, I'm here to say that, yes, there's definitely a solution. And what we can do is we combine off-chain computation. So we're not going to use blockchains directly, right? Because we said that was too hard. But we are going to use these TEEs because they seem really useful. And we're going to use this remote attestation process that the TEEs give you, but then post those attestations publicly on chain so anybody else can verify. So this ensures that the applications are scalable, and note the color coding here. Off-chain gives you scalability. TEEs can also give confidentiality, and the process that's used, remote attestations, makes them verifiable. And that's great, because now we can unify privacy, crypto, and AI. We've kind of had a little workaround. We're not running them directly on chain, but it does still use blockchains for a desirable outcome. And so to be specific, the way that we've built this is a system called ROFL. And it is not the acronym that you're thinking, but that was intentional. It's called Runtime Off-Chain Logic. And it's basically a way for developers to create policies which can anchor on-chain on Oasis Sapphire or any other network. So the idea is that you have a coincidence of needs. You have node operators that have hardware, they have this TEE, they want to be able to get paid for their services, and they can run specific binaries and that they're given by some developer, maybe a smart contract developer, or just any other application in principle. And the node operators can remotely attest that, yes, I'm running the software that you gave me. So you're essentially trusting them in a sense as an oracle. But you're not trusting them because it's not true trust, because you can still actually verify what they're doing. But they are acting as a centralized cloud provider in a sense. And by doing this, you can run arbitrary software in containers, and you can also, in principle, do LLM inference and training directly inside of these nodes, which have these TEEs. The way that this works with GPUs is in the NVIDIA H100, which natively at the hardware level supports this confidential compute system. So it wouldn't really be possible without that, but this is something that we're working towards integrating this year. Currently, the Intel TDX, which is the CPU side of things, is up and running though. So this is just a very simple diagram of how Raffle kind of connects with everything. So it connects with the on-chain logic world. It can connect with other blockchains. This is something that would normally be referred to as a bridge, but it can also get external queries and make HTTPS calls, and it can run clients for other blockchains, right? So it can do all these things because it's not actually on a blockchain. It's just interfacing with blockchains and attesting onto them. So if we're able to do this completely off-chain, why would we really want to use Sapphire then? Because naturally, blockchains are just going to be more expensive. They're harder to work with. They have more restrictions on the type of applications you could run, right? We have block times to worry about, confirmation times. Blockchains are nice, but they're not as good as just running things centralized if there's no worry about security or anything like that. So what are blockchains actually still good for? Well, they are actually still good for things like payments and the final execution logic, what might be referred to as settlement. This should still be handled on chain because at the end of the day, we want users to have persistent control of their funds over a long period of time that is not still controlled by any single party. They might delegate control of their money temporarily to another application, but they want to be able to get that money back and regain control for the long term. So blockchains definitely should still be used because they allow for things like payments. And this creates kind of a hybrid system where we have decentralized rails, but we can also have flexibility in certain parts when we need greater feature richness off-chain. So it's a combination of the two. We have the confidential smart contracts, the off-chain TEEs, and this gives you full end-to-end encryption as a result. That's also a nice benefit of using both of these systems. This is all kind of, hand-wavy in a sense that it's saying what the tech can do, but let's think of a specific example of how this would actually be implemented. And right now we're seeing there's a ton of interest in AI agents. So let's use that as an example. If we have some autonomous AI agents, it could run off-chain in principle, and it can manage some on-chain wallet. Maybe it's doing some sort of trading, some sort of sentiment analysis to handle price predictions. It could be doing all sorts of things. But if it's off-chain and it's on a centralized server, even if that server is attesting that it's behaving correctly, it still begs the question of who controls the private keys in this case. Well, what you can do is use Oasis Sapphire as a decentralized key manager. And so this actually facilitates the access controls for that AI agent. And so even though the agent itself is running in a centralized way, its ability to access funds can be decentralized. And you can also use the blockchain in this case to do things like storing message history persistently, but in a confidential way. So if a user wants to, maybe their AI chatbot is some sort of personal assistant or a therapist or something like that, they want to be able to have this memory and this message history to refer back to, but we don't want to necessarily store it inside the Raffle application because you might lose that message history. So storing it on-chain means that that data can now be more composable. It can be used in other applications. It can persist for the long term, but all that can still remain confidential. So you're actually increasing the value of your data while getting better control over it at the same time. So there's still a lot of benefits to this on-chain world interacting with these off-chain applications. We actually built a demo chatbot that showcases this and how it would actually work. So if you go to the link here, playground.oasis.io, you can search chatbot and it'll come up. And yeah, we built it on testnet, and in the GitHub, there's lots of information of how it works under the hood. So if you're a developer, I would definitely check it out because it was very informative to me, at least, and I'm not a developer. But yeah, so that's basically Raffle in a nutshell. The only question is, well, how far along is it, and when can I expect this to be, fully working if I want to be a developer? Well, it initially supported Intel SGX on mainnet, so that was already accomplished. But that requires apps to be written in Rust. Intel TDX, which I mentioned before, but I didn't really explain, this basically gives a way to have more generalizable apps. And so you can basically just package up your application in a container and send it to a node operator and say, hey, run this. This is also available in mainnet now. However, there's a few drawbacks. The main one being there's a much larger trust computing base, meaning in an ideal world, nothing bad is going to happen. But if the application is not built in the right way, or if there's an SGX or TDX exploit, you do run, generally speaking, a greater risk of some sort of data compromise. So if you are maximally security focused, you might still want to use SGX. But that being said, we are up and running with TDX, and the next thing to come is a Raffle marketplace, which will really facilitate connecting the hardware operators with these application developers. So you as a developer don't have to worry about running your own hardware, because that is obviously a major impediment to actually getting things done. So we want to make that as easy as possible for you. Also, I had on the bottom here that, of course, we're always working on better documentation, but that's an evolving process, so that never ends. And NVIDIA GPU support should be coming this year. We've purchased an H100 in order to do testing and in order to potentially offer other services to come. But we would really like to see AI that is running in these TEEs. I really want to hammer the point home that you shouldn't really be trusting any agents if they're not verifiable. And you really shouldn't be trusting them with your data if they're not running inside of a TE or using some other confidential compute system. So if the AI agent is just running in the cloud somewhere and you're just giving it all your data, you're just handing your data away. And this is something we probably shouldn't be doing, because in my opinion, LLMs and AI are actually going to be not just an extension of the last 20 years of data breaches and things like that. Even if there's no data breaches, what I'm trying to say is people have been giving away their data for a long time, and that has not really stopped. But now that AI is here, I think people are going to be much more willing to give away really sensitive data, their internal thoughts and feelings and things like that they normally would not have typed into a computer. Now it's going to be sent to a cloud, and it's going to be analyzed and used for all sorts of purposes. So people really should be careful about the data that they send out, and they should be cognizant of this. But not to be a doomer, there are solutions. So it is going to be okay. We just have to be smart about it. So that's all I have to say. If you're interested in Raffle, please check it out at the bottom here. Here are the docs. But otherwise, I just want to talk about, showcase a few of the grants that we announced in the last couple of weeks. Tamarin is going to be using Raffle for healthcare data privacy. We also awarded a grant to Diode, which is one of the partners I've been working with, and they just launched their token today, so I wanted to give them a shout out. But they'll be working on Sapphire. Basically, they have this zero trust network system, and they anchor policies on the blockchain. I won't go into the details, of course, but feel free to check these out. They're pretty interesting. So thank you. Here are all the socials. If you're curious about our Twitter or Discord or Telegram, we do have a Sentinels program, just an ambassador program, but that's how we brand it. If you're interested in developing, you can apply for a grant as well and get in contact with me directly. And we also have a university program, which nobody should be surprised here. So yeah, of course, we're always looking to have outreach to more universities though. So if you have contacts with any other groups or things like that, we're always happy to do what we can to spread the word, talk about blockchains, privacy, AI, and all the rest. So all right, that's it. I won't blab anymore. Appreciate all your time and attention, and that's it.
Does anyone have any questions?
I have maybe a little.
Yeah, if you stand up a little bit and big.
Thank you very much for interesting technology. I have a question about this use case scenario where you were talking about how the OSs can be used as a verification layer to servicing like large language models. So I think just understanding the way current like large language models are serviced in the internet, they don't put the response all in one batch, but they stream it. So each token is delivered for each API request. But if which require
Sorry to interrupt. I can't hear anymore. I think something flipped or switched or something.
Shut down. What?
I can hear now. Okay, we're back. Thank you.
The system resets at 10 p.m.
Yeah, it's 10
So-
p.m. Yeah, so I think that that's the time we're going to leave, so the system just like reset itself.
yeah,
Oh, okay.
Okay.
probably less delayed questions the next time.
Can you tell the person again?
Okay.
Yeah.
So my question is, for the latency critical system, I wonder whether, like Oasis or adding another layer of service that would create are we resetting?
No, just come here.
Yeah, would increase the latency. Just like, I mean, it's not really similar to, but you know, one of the weak points that Bitcoin was kind of criticized by in the early stages because of its high latency, right? Transaction takes like tremendous amount of time. Forcing the case not because of the network latency, but because of the complexity. But in any case, what I'm pointing out here is that for the end users, the time it takes until their service is delivered is quite critical. And I wonder if Oasis doesn't suffer from any of those kind of issues.
Yeah, that is an excellent question. So there's two aspects to this. So with Raffle, this is actually entirely off chain. The attestation part does not affect latency. So as far as scalability and latency are concerned, I would say you can pretty much assume it's zero. There might be some small imperceptible difference, but it runs more or less as a Web2 application. However, that being said, we did the demo chatbot, for example, that I showed, that we built in a different way. We didn't build that for maximum speed. We built that as a showcase of kind of what you can do. And so that actually anchors all of your data on chain. Every time you send a prompt, it's sending a transaction. And then the chatbot reads that from the on-chain data that's stored. So that will add quite a bit of latency. You're gonna have to wait for the transaction to confirm, for it to read it, and then give you your results. So to answer your question, yes, it can add a lot of latency, but it just depends on how you build it and what you want to do with that system. If you want everything off chain and no persistent storage, then you can make it just as fast as any other app.
Thank you so much. I'm sure we'll be doing more of Oasis soon anyway, so that was really great. Really appreciate it.
Yeah, no, my pleasure.
Thank you so much. We'll speak soon.
All right, thank you.
Thank you. And